In this video, I'm going to talk to you guys about turning points and how we can use our graphing calculators to find turning points, and also about what they tell us about the polynomial function that we're taking a look at. So, to begin with, just to get an idea, generally speaking, of what a turning point is, let's say we're looking at the graph of a polynomial function, and it does something like this, right? Now, we've spent a lot of time so far talking about, special coordinates where we hit the x-axis. You guys all know those are called zeros, right, or x-intercepts. But what we're going to focus on right now is something that is also very interesting about polynomials, and those are the points that are either at the top of the hill or at the bottom of a valley in a polynomial graph. So these points that I just kind of highlighted in green, those are kind of called local maximum or minimum, or turning points. And I think turning points is pretty straightforward because that's where the graph takes a turn from one direction to the next. So each of these points in green are called turning points. And actually there's special names for each one of them. So if you're at the top of a hill like this guy, this is called a local maximum. And if you're at a point down here, like at the bottom of a valley, this is called a local minimum. So when we look at a polynomial, the local max and the local min, another thing that I think some students get confused with, the local max or the local min, so the local max slash min is really the y coordinate is the y value of the turning point, not the x value. So really, when we talk about the local min, if we were to find really what that is, that's that y value that we would have that corresponds to that point, and kind of the same thing for the local max. That would be really the y value of that coordinate that is considered the maximum. It's like the highest, value of y in this local area. And for local min, this is the lowest value of y in that local area. So there's also a couple points to remember. So two major points to remember and study. So those are as follows. First of all, number one, a graph of a polynomial of degree n will have at most, that almost looks like a J, doesn't it? Let me change that to at most n minus 1 turning points. So that's at most. So we'll talk about that and an example. And the second thing that's also important to keep in mind is if a polynomial of degree n has n distinct, which means really just different, right? If they're distinct, they're different, but we're talking about n distinct zeros, then there must be n minus 1 turning points. So let's practice a problem which you might be faced with going forward. Let's do the following. I want you to, and we'll only do one example, I think you'll be okay with it. I want you to use your graphing calculator to graph the following function, f of x equals x to the fourth minus 6x cubed plus 3x squared plus 10x minus 3. And what I want you to do is identify the x-intercepts, which we've done before, and the new part will be all local maxes and local minimums. So we'll do that in a second, but before we do, just a quick note. The degree for this polynomial is 4. So that means I should expect at most that number 4 minus 1, which is 3, right? I should expect at most 3 turning points. Now I don't know until I graph it if I'm going to actually have 3 turning points. I may have 0 turning points, I may have 1, I may have 2, but at the most it would be 3. It would be impossible because it's degree 4 to have 4 or more turning points. At most it's 1 less than the degree. So this is what we're going to do. Let's see if I can pull up my graphing calculator. Where is my calculator here? Okay, so I was able to get the calculator. So now, of course, what we're going to do is go to y equals, and we're going to type in our function, x to the fourth. There's our x to the fourth minus 6x cubed and plus 3x squared plus 10x minus 3. And I'm going to go to zoom 6 to graph it in the standard window. Now this is a great example where I don't get a full picture, and in this case it is important that I do get a full picture because the way it stands right now, I'm missing one of my turning points. I can see I have this guy here, and somewhere down here would be a turning point, but I can't see it. And it does look like I should have 3 turning points, which actually makes sense because do you remember that second point to remember? If you have a degree n and you have n different zeros, you're going to have n minus 1 turning point. So in this case I had 4 zeros with a degree 4. There's 1, 2, 3, 4 zeros, so I have to have 3 turning points. So what I'm going to do in order to be able to see this part of the graph is I need to lower the bottom of the screen, which corresponds to my y min. So I'm going to go, change the y min a few times and kind of see what will work as a good viewing window. So to change your y min, you're going to go to Window, and for y min, I'm going to try like -20, and then I'm just going to hit Graph and see what that looks like. -20 is still not low enough, so I'm going to change that still yet. So in the window, I'm going to go, let's say -50. Just jump down a little lower. Okay, so -50 definitely does work. I can see kind of all the important turning points, and I can still see my zeros. First thing I'm going to do is find the zeros. Now, that is something we've done before, but I'm just going to go ahead and run through it quickly as a quick reminder. To get the zeros, or the x-intercepts, you have to hit second, then the trace button, and then I'm going to choose 0. Now the first 0 I'm going to get is going to be the leftmost 0 the one that looks like it's around maybe -1 or -2. Now the left bound, right now where my crosshairs are, where I'm a little bit above that 0, would be just to the left of that last 0, so I'm going to hit enter. And then right bound, I'm going to pass that 0, so I'm below it and to the right of it. I hit enter twice, so my first 0 is -1.14 if I round it. I'm going to do this again to get that 0 that looks like it's at the origin. I'm going to hit second trace. I'm going to choose 0, number 2. Now, if I'm at that origin, I want to be to the left of it, so right down below is to the left. Hit enter. I'm going to go above, hit enter, and hit enter a third time, and that looks like it's 0.29. And I'm going to do this a third time. Choose 0, and I want to find this third 0. I got to make sure I'm to the left